Okay, this video will correspond to roughly section 2.6 of the textbook. The topic is categorizing statements. And here's what that means. It's for a single statement. We'll talk about relations between two or more statements next. But for now, we're talking about a single statement. It's often useful to know the range of truth values that a statement can have. So there's three categories or three possibilities that are interesting here. On the one hand, there are statements that are always true, and we're going to call those tautologies. There are statements that are always false, and those will be contradictions. And then there are statements that could be either true or false, and we're going to call those contingencies. So by definition, an atomic statement can be either true or false. So atomic statements are all going to be contingencies. Okay. What about compound statements? Well, compound statements could potentially be in any category. There can be compound statements that are tautologies, compound statements that are contradictions, compound statements that are contingencies. So here's an example of a compound statement. P or not P. Now, if we do a truth table for this, P can be true or false, not P will be the opposite, false, true. You can see that this compound statement is always going to be true. And you can not only see that from the truth table, you can also just sort of think about it. Not P is always going to be the opposite of P. So if P is true, not P is false. If P is false, not P is true. Okay? So one of these is always going to be true. A disjunction is true if both or either disjunct is true. It only takes one disjunct. Well, we already know that at least one of these is going to be true, so by the truth function of disjunction, you know that there's no way you could possibly make this statement false. So this is an example of a statement that's always true. Okay, this is a tautology. Okay? What about B and not B? By the way, let me go up here to determine, oh, okay, yeah, I want to talk about this. So I'm going to go through what I just did, but sort of formalize it a little bit. To determine whether a statement is a tautology, contradiction, or contingency, you do kind of what I just did with P or not P. You do a truth table for that statement, which is what I did here, and then you look at the truth column for that statement. That's the column of T's and F's underneath that statement, the column of truth values. If it's got only T's, then it's a tautology. And remember, this one had only T's. If it's got only F's, then it's a contradiction. Okay? If it has both T's and F's, then it's a contingency. And it doesn't matter what the proportions are. Okay? It could be half and half. It could be 127 T's and 1 F. As long as there's both T's and F's, it's a contingency. Well, here's the truth table, here's the truth column, and if you look, it's only T's. So that's a tautology. What about this? B and not B. Well, we do the same thing. Well, first off, before we do the same thing, notice you should hopefully be able to look at this and tell that it's a contradiction. And the reasoning is similar to the reasoning for P or not P. B and not B will always have opposite truth values. If that's true, that's false, and vice versa. A conjunction is only true when both conjuncts are true, but both of those conjuncts can't ever be true. If this is true, that one's false. And if this is true, that one's false. So the conditions that would make a conjunction true will never be satisfied. Okay, so that's why this is going to be a contradiction. But we can do it the old-fashioned way. We can just do a truth table. B, not B, B and not B. Top half trues, bottom half false. That's just the opposite of B. And there's the column. We're going to look for any row where both conjuncts are true, and you can see there's no row where both conjuncts are true. And so because the truth column is only F's, that statement is a contradiction. What about a slightly more complicated statement? Here you may not be able to just look at this and tell if it's a contradiction, contingency, or tautology. But it doesn't matter. You don't have to be able to just look at it. You do a truth table, you look at the truth column, and then you just determine on that basis what category it falls into. Well, here's our truth table. We're going to need 4 rows because we have R and S. We have 2 atomic statements. We're going to need R, S, S or R, that's 3, not S or R, 4, and then the whole conjunction is 5. So 5 columns. Alphabetical order, true, true, false, false, true, false, true, false. Disjunction, it's true, it's only going to be false when both disjuncts are false. Here's the disjuncts, they're only both false on row 4. This is just the opposite of that, so instead of true, 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 false, it's going to be false, 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 true. And here's the conjunction. Conjunction is only going to be true when both conjuncts are true. Column 1 and 4 are the conjuncts. Conjunct 1, conjunct 2. Is there any row where they're both true? No, no, no. So there's no row where both of those are true. It's false all the way down. So this statement is a contradiction because its truth column contains only F's. Okay, this is a short video because this is actually a short topic. In order to determine if a statement is a tautology, contradiction, or contingency, you just do a truth table for that statement. You look at its truth column. If it's all T's, it's a tautology. If it's all F's, it's a contradiction. If it's any combination of T's and F's, then it's a contingency. And that's it. The next and final video will talk about relations between statements.